Hello, I'm JW. This time we're going to be assembling the Autotransformer, and that's one we've seen in a couple of previous videos. So we're going to be putting it into the case. We're going to use the original case, but it has been repainted. And we're also going to be fitting various other things on the front, including making a new front panel for the thing, and of course various other things will be attached into that. Now this video comes in two types. This one is the short version, which basically covers all the stuff, but obviously a lot of stuff been edited out. There's also a longer version, which, as the name suggests, is extremely long and covers everything in extreme detail. But this one is the short version, and if you've seen the other one, then this is basically the same content, it's just obviously a cut-down version of it. Now we'll start with just having a look at the components we've got here. So, of course, the transformer itself over here. This is the case, which I have repainted. It's a metallic colour, and it's called gunmetal, which is basically grey. Metallic there, steely dark, industrial metallic it says. So there's that. So I've already painted these, obviously we're not going to be showing that in either of the versions of this video. So I have some wire here. This is for the internal wiring, and this is where the mains flex will go in. And we've got some of these things here. Now this one is a voltmeter, and we can see that it just goes 0 to 500. Two terminals on the back, and then we've also got some other ones as well. Here's another voltmeter, and again this goes 0 to 500, so the idea here is one is for the input, one is for the output, and then we've actually got two of these which show the current, and those go 0 to 10, and again they're direct connection, no external components needed. Those came from China. This is the original handle which went on the top, so that will be going back in that position. The front panel, as we see on this bit here, has a massive gaping hole in it, so we're going to be actually covering this whole thing over with a new panel that's going to be made out of this stuff here. This is aluminium composite, or also known as dye bond and various other names. I have shown this in a previous video, but we'll be basically cutting a piece out of this with various holes and things as appropriate. And then that will just go over the whole front of the panel here. Rubber feet here, which will go on the bottom. Two handles, these are actually on the front here on either side, so when we put the things in the middle it won't get bashed in by things obviously from the front there, so just sort of protection purposes. New mains plug for the lead. Panel mounting socket, this one's made by MK, so that will go in the front as well. And we have a neon indicator here, this is orange one. This is actually made by Arc Electric, which was the same make as the old one that was in there. I actually have two of those, not sure whether we use both or not. And for changing the actual tappings on the transformer without having to open it, we have this delightful switch, and it's a 4-position switch, so 1, 2, 3, 4, which gives us 4 tapping options from the outside without having to open up the case. And this is a very small switch, as you can see. Had to get one of this size because when that transformer is in the case, there's not actually a whole load of space inside, so this happens to be the one which will fit. Still have enough clearance behind to get that fitted in there. And that's pretty much all the components we've got here. The only other thing is a piece of flex for the actual mains lead, which costs, we'll just get some appropriate one for that. That will go in the back via that thing, and then say the transformer itself, and there'll be various bolts and things to fix all of this stuff together. Now this is the top of the case. I've refitted the handle here. It's just 2 bolts that go through. And what I've also done on the inside, I've actually fitted a lead here for the actual earth connection, and just put that under one of the bolts there to basically clean off a bit of the paint underneath, and then just crimp on a lug and secure that down. So this will act now as the earth connection both for the handle and also the whole top of the case, because of course we don't really want to rely on the little holes where it screws into the bottom one. It's all basically painted on all sides. So that's the top part there completed. Now these meters came from China, and being from China they were incredibly cheap, just a few dollars each. If you bought them in the UK then they would have been 10 times the amount. And I got these ones because of the sort of retro type of look here, so basically round there with the analog dial or movement there. This plate goes behind, so we'll just see the round part through the front panel. Now these, just going to check these just to make sure that they are in fact what they claim to be on the front, because of course if they weren't we could end up connecting it and something could blow up. So just going to turn the meter here to resistance, and we're just going to check the resistance of these things. Now these are voltmeters which are designed to connect directly across the supply up to 500 volts, so we would expect that the resistance between these is extremely high. You would hope in the order of megaohms. So let's just check these. These are actually marked plus and minus, but for AC of course it won't actually matter. However, it may matter in terms of testing. So Let's just connect up the minus and the plus, and we should see a fairly high resistance here. So seeing about 2.8 megohms. That doesn't seem too bad. Let's just see what it would do in the other direction. Yeah, so it's actually open in the other direction, so there's presumably some diode or something inside to rectify, because obviously, although this whole assembly is rated for AC, the meter movement itself, of course, won't work on AC, it will be DC only, so that's fine for that one. So we'll just put that out of the way. These ones are the same casing, but these are actually amps, so what we should find, and this is the exact opposite, we should find an extremely low resistance between these, as these have to be connected in series with the load, and of course any kind of resistance there would mean they would heat up and set on fire. So these go from 0 to 10 amps, and because these are a moving sort of analog scale, it's sort of more condensed at the two ends, so 2 of course is pretty much down there, but this thing is rated up to 2 kVA, so that's in the region of sort of up to 10 amps or so, so perfectly reasonable. Now again, these are marked plus and minus, but let's just try the proper way round, and we should get extremely low resistance, so 0.6 ohms. Let's check what the leads measure. 0.6 ohms, 0.5. So we're looking in the region of 0.1 ohms. Again, that's perfectly reasonable. Basically, we want it to be as close to 0 as possible. Oh, it's the same in the other direction, so again, that's exactly what you'd expect, because of course current flows in both directions on AC. Now this is the switch here, and you see it's got terminals on both sides, so 1, 2, 6 and 5 there, 3, 4, 7, 8 on the other side. And the way this should be configured is that the input, as in it's common to all the switches, is actually number 2, and then 2 is also commoned up with the other even terminal, so 2 and 6 there, 4 and 8 are all common together, which they are, I've just checked it with the meter. And then the outputs are the odd numbers, so it's basically 1, 5, 3 and 7. That depends on the position, of course, of the selector switch on the front, and again I've just checked those are all actually correct. Now of course there is a diagram that comes with these things, so this is actually the one with the switch we're using. It's a K10D004NCH, and it basically gives you the diagram here for the inside of the switch and the various positions depending on where the selector is located, and also the angle of the switch and everything as well. So basically it complies with that, which is no surprise, as this is a decent switch, and this definitely was not a cheap one. In fact, it cost more than the transformer itself. Now for the front panel of this thing, we've got a load of holes here from previous stuff that was installed, so we're going to actually cut a piece of this die bond, which is an aluminium composite, and just cut that to fill the whole thing, and then we'll have various holes in the front there, which of course will ensure we can install our meters and other items in there fairly neatly, and then of course we'll have to cut out some bits in the back here to match up with the holes in the front. This is the model in Fusion 360, so it's just the 2mm thick panel. I've sized the outside to the correct size that will fit on the front of the metal case, and then we have various holes in the middle here, those large ones for the meters. This will be the socket at the bottom, 2 of the neon indicators and the 2 switches, and then some text to just put there for in and out. So relatively straightforward there. If we have a look in the manufacturing tab there, then we can see what that will look like in here. And if we go to the simulate tab, we can see how the cutting is going to work. So basically it's going to be in 2 tools we're using. The first one is this end mill here, which will just cut out the outer perimeter and of course the larger round holes. And then on the one after that, if we move forward, then we're going to use a engraving bit. It's not actually as big as it looks there, it's just how it shows there, but essentially that's going to be used to engrave the text, both the in and out there. And then it's just going to mark the position of these other holes, which are fairly small, they're only 4 and 5mm, so just going to mark the position of those, and I'll drill those out separately later on. So 2 tools we're going to be using, so here's a quick look at those 2. They're both 1/8 of inch shank there, so fit in the same collet, and so one is just the end mill and the other one is just that very sharp, pointy engraving bit. So here's the panel, and so there was a bit of a problem there. It didn't actually cut deep enough on the first pass, so I adjusted the settings, did another pass, but bizarrely it showed in Fusion as cutting to the bottom, which the edge did, but the middle only just skimmed the surface. So having to set an extra 2mm depth, it went down to the bottom, but bizarrely that showed in Fusion as cutting 2mm below the bottom, so I'm not entirely sure what the problem there was, because say the outside and the middle were done on the same thing, and the outside was fine and the middle wasn't, and it did show as the bottom of the cut rather than the or the bottom of the hole rather than the top. So anyway, some bizarreness there. Anyway, so we've got the holes here, got in and out for the input and the output voltage. The holes on the things here for the screws I didn't drill on the machine, I just basically spotted where they would go. Just drew those on the drill press because they're different sizes. In theory you could have put a drill bit in the machine and done it, but it's just quicker to do it on the drill press in that case because they're just straight through holes. Now I've cut the panel here just to cut out a big hole there for the various items and just put some more paint over to cover up the bare metal edges. This is the panel, and essentially I put the socket in already. This will just sit over those holes like that. The meters here will just push in from the back through the 4 holes there. Got these neon indicators which will just drop in and again screw in from the back. And then our 2 switches, one of which will be in here. That's for the tapping selector. And I've got this toggle switch here which we'll put in from the back. Just using on and off power. Now the next thing is to fit these meters in, and so they just push fit into the back, cut the holes so that they are a sort of friction fit there. Just push those through like that. Now obviously they don't necessarily stay there if you press on them, they will fall out, so I'm going to put these in and then we're just going to glue on the back here to secure them in position. Now I'm going to glue in with this mitre bond. This is basically super glue, and comes in this bottle. There's also an activator as well which will cause it to react far more quickly. So basically I'm going to put the glue onto the 4 corners here, so just put a little bit onto there, and then we'll put the activator on the back of the panel, and of course when the 2 meet up then it will be bonded permanently and forever. You can of course just use normal super glue, but the problem with that is it takes quite a while to set, whereas this stuff, say, is much quicker and generally far more robust. So I'll just do one of those, and then the activator we just spray on the back of here. Doesn't need a huge amount of it, just have to wet the surface, and then I'll just shove that in and repeat likewise on the other 4. So next thing is just to put it onto the panel here. So I've glued those in with the super glue on the back, so then we don't have any screws showing on the front, just looks a bit tidier. You can imagine if there's sort of 4 screws around each one, that's another 16 screws all going through the panel, so fairly untidy. Now these neons have to go in after, because the whole point of these is that we can use the screw on the back, or the nut on the back, to actually clamp onto the metal tab as well, so they go in afterwards. So I put those 2 nuts there. I'm going to leave those slightly loose for now because we may need to adjust the exact position of the panel once we put the handles on. These just go on the front and then the screws go in the back. Here are the screws. I had to cut them down because they were supplied this long, absolutely ridiculous length, so to reduce the size. And I'm not entirely sure what this thread is. It doesn't appear to be a metric thread, it's something else, so otherwise I would have just bought some, got some shorter bolts from the cupboard. So anyway, we just need to put the screw through the back, and then it will come out on the front panel, and it's a question of attaching the handle on the front. And again, this will clamp the actual front panel, the new one, onto the existing case, so then we don't have to actually bother with putting extra screws to hold it in position. Now this switch, in theory, it's supposed to have a sort of a cutout in the panel, so that this notch in the actual switch, it's on the top there, actually has a sort of corresponding tab on the panel, but the realities of cutting a round hole and leaving a little bit sticking down are pretty next to impossible. So what I've done instead, I've actually cut this hole so we can basically thread the switch into it, sort of like that. So it's not going to be sort of loose or anything there, it can actually, in there it's pretty secure. And then it's going to obviously put the locking ring on the front, so hopefully when we get it in here we can obviously tighten it up to a reasonable degree, and then obviously we can put locking around the front, and that will secure it in place. Now the next thing is going to be to do all the wiring on the front here, and of course we need to do that before the transformer goes in, because the transformer, as you see where the holes are on the base, that will actually come up to virtually the back of all of this, so we need to do all this wiring here first, and then the transformer goes in, and then the wires go on the top to connect to the various terminals. Now for the end of the wire we're going to need some of these. These are pin terminals or ferrules, and basically they will just go over the wire there, crimped down, that we don't have any stray strands of wire flapping out. That's obviously a bit long there, just to strip that for a random length. And then for the others, got these rings here, and again these just crimp onto the end of the wire. Again, that's far too long, obviously it will be crimped on the end like that. And for the other things with the press-on connectors, then it's these things, and again they'll just crimp on the end as well. So various different styles of connectors there. One thing of course is, do these in fact fit on the back of here? Let's hope they do. Well, unfortunately they seem to fit perfectly, so no problem with that. So now it just remains to get all this wiring and gubbins together and get the whole of this wired up, and then we should just end up with the wires from this coming up to the transformer, and then we can put the transformer in and get it sorted. So I just stripped off a moderate length on there, and we'll just shove that through the fitting like that. Now we're going to want this to go along the side of the transformer like so, and then we're going to want it to go to the front somewhere here, so that should give us enough length. Some of those are going to go to the switch over there. We're going to need to put some additional connectors in somewhere as well, but that should be a reasonable length. So if you bring it up to the front, then what we're going to do is put these cable ties around the flex. I'm going to put those up at the end here. I'm going to put another one on the basically the other way up. So yeah, it's got to be that way around. Now that one we're going to tighten as much as possible and then cut off. And the other one we're going to put just against that on the same piece of cable there, but sort of opposite. Tighten that up as well, and we'll cut that off as well like that. Now the reason for these is these will grip on the cable and stop it pulling through, so see that will stop it going through there. Because this thing on its own is just a rubber seal, and that will grip on the cable. They don't grip all that well, so in theory if you pull this, or over time it could gradually creep out of the equipment, but with these things they'll prevent that from going through, so it's generally a much better idea just to have that on the inside, and then this will just seal down to obviously prevent dust or whatever getting in. So we'll just tighten that down to a reasonable extent like that. I've already tightened on the fitting, so that's now secured in there. So there's our lead on the end, so we've got a couple of meters of length on the end of that. Now I've completed all of the wiring on the inside and also put all the stuff in the panel. So here is the front panel. Here is the selector switch for the 4 tappings from the transformer. Power on off switch, socket here, and then we've just got the neon indicators, and this will be the voltage in and the current in and the voltage out and the current out, and of course the voltage out will depend on what tapping is selected, and of course the current then will be proportional on each. And on the inside, as well as the white mains lead coming in there, which we saw earlier, I've got all the rest of the stuff. Now in terms of fitting the transformer, we just sit over these holes inside, and how this is going to work, we're going to put these rubber feet on the bottom. These have a metal insert inside, and they're actually made by Penn Elcom, and they're actually made in the UK, not China. And these are M6 threaded, or well, it's M6 clearance holes, so this M6 screw here will go in, and then you see it's flush on the bottom. That goes underneath, pokes through, and then the transformer will go on top of these, and then we'll just put the nut on the top to secure it in position. So that's the wiring inside complete. So we've got the neutral connected here, with mate L1 there, and then the other wire on this one is the supply, so we're going to put that in here where it's marked 230. And then we have the 4 outputs, which are marked 1, 2, 3 and 4 here. So basically 2 of them will give us a lower voltage there, and then 2 of them a higher one. So it's basically 200, 215, 245 and 260, and those are the ones that are controlled by the switch on the front panel. Additionally, I'll put a fixing here. So basically this wire is what goes over to the lid, so the earth for the top piece, and then the other one here goes down to the earth connection on the socket, and the earth from the mains lead coming in actually goes to the socket as well. So it's basically coming in to the socket. This goes up to the piece here, which again goes through the actual frame and everything else, and then the one goes over the lid as well, and the transformer itself of course is bolted down to the bottom to make sure that the bottom half is earthed as well. So there is the finished item. The plug here, there is a relatively close to the bottom, but we've got the space here and also the gap where the feet go, so it does actually fit there perfectly well, so not a problem. Not really anywhere else you could put the socket other than on the top or the side or something, because obviously there's only so much room on the front panel, but all fits there okay. So basically it's on and off here, and then your 4 voltage selections over there, and then it's voltage and current in, and voltage and current out, and then of course the 2 will light up depending on whether it's on or off. So here it is in the on condition, and we can see the 2 voltages marked there, obviously the input and the output. In this case we're on the bottom one, which is basically reducing the voltage to basically about 212 on the output. This is just connected to this blue lead here, and we can see there that the voltage going in is the usual sort of 245 or whatever it is normally here, and the output of course is slightly lower there. Current of course is 0 because there's not actually any load attached other than this meter, but if we plugged a moderate load in of course that would show there. And if we change up to the next one, see now we've got 228 coming out there, and again if we move up to the next one, that gives us around 259, or well 260 nearly, and then if we turn to the top one, then we get about 275 or just under, and again the meters obviously show the general indication of that. So that's pretty much complete now, and so this switch here is basically the power on and off. So with the power off, we've still got the input power there of course, because still connected to the supply, but the output of course is off, and also it doesn't actually show the voltage there as it's not connected. So that's the transformer completed, and so we've got it set there so it can have 4 choices. In this case it's 2 lower and 2 higher, but obviously there's other tappings in there, so we could simply move those around as needed whenever. So whatever you've got you can choose from any 4 of the output voltages that it has. And so in this case, say it actually goes up to about 275, even though that top one is marked 260, because of course we're fitting it in on the 230 tapping, and so the voltage in the UK is generally around 240 or so, despite the fact it's supposed to be 230, but doesn't particularly matter, it still works just fine. So that's it for this time. We'll be seeing it of course again in no doubt in future videos, but until then, thanks for watching.